Hello everyone, let's start another lecture. A circuit can have any number of elements that make up its framework. The more elements usually means the more complex the circuit. If possible, elements in a circuit can be manipulated to make the circuit easier to read. Today we will talk about resistors combinations. Resistors can be combined in series or parallel. The combinations can be used to find the equivalent resistance. That is the result of combining two or more resistors together. If you remember, elements in series share a node and the current passing through it are the same. Here is a single loop circuit with the resistors connected in series. The equation represents the equivalent resistance of series resistors where N is the number of resistors. To find the equivalent resistance of this circuit, add the values of the resistors in series together. On the other hand, we have parallel combination. Do you also know how to identify elements in parallel? Two or more elements that share two nodes are in parallel. They also share the same voltage. In this circuit, all the elements are in parallel. Resistors in parallel are combined differently than series resistors. R1 and R2 share nodes A and B, so let's see how to find the equivalent resistance. The equation represents the equivalent resistance of two or more parallel resistors. N is the number of resistors in parallel. Adding the reciprocals of the resistors in parallel will give the reciprocal of the equivalent resistance. Finding the reciprocal of that answer will give the actual equivalent resistance of the resistors in parallel. Here's a simpler equations for equivalent resistance for two resistors in parallel. To the right is the equivalent resistance of the two resistors in parallel. Here is an example. Find the equivalent resistance of the circuit. Start off by labeling all the nodes. Start from the right of the initial nodes of A and B and work your way till you get a single resistor. Resistor 4 and resistor 7 share node F, so they are in series. The equivalent resistance of that will share node G with resistor 6, making it also in series. You can look at it another way, since the resistors from node E to node D have the same current, they are connected in series. Resistor 8 and the equivalent resistance share two nodes E and F, meaning they're in parallel. Resistor 3 and the equivalent resistance share node E and the current is the same, so they are in series. The equivalent resistance and resistor 5 share nodes C and D. They are in parallel. The equivalent resistance and resistor 1 share node C. The equivalent resistance also shares node D with resistor 2. The same current passes through all the resistors, so they are all in series. Here's the equivalent resistance. Now for another example that is a little bit more complex. Calculate the resistance RAB. Resistance RAB is the resistance from the point of origin being nodes A and B. This will also be the equivalent resistance. All the nodes are already labeled, so one step is out of the way. Let's start from the right side. Resistor 3 and resistor 6 share node E and the current is the same, so they are connected in series. The equivalent resistance, resistor 5 and resistor 8 share node D and B, so they are all in parallel. The equivalent resistance and resistor 2 share node D, so they are in series. The equivalent resistance, resistor 7 and resistor 4 share nodes C and B, so they are in parallel. Resistor 1 and the equivalent resistance share node C only, so they are in series. Here's the equivalent resistance. Also, the equivalent resistance will keep on updating till it cannot update anymore, like we have here. Thank you all for listening. Till next time.